Hi everyone. So I think most of the people are here. So I just share the screen. Is the screen visible to everyone? Am I audible?
Yes, sir.
Okay. Wait a second. I increase my volume. Think. Okay. So today we are going to discuss about the null space of A. A is a matrix, right? Any matrix, range space, and yeah, so these things and rank nullity theorem. Yeah, like this, and the dimensions, whatever is that. Okay, so what is null space? So if you define null space, then it is denoted by an A, and which consists of elements. So I just write. So I have already described about the linear transformation. So linear transformation is just a function T from a vector space V to a vector space W, which is a linear map. It satisfies this thing. W is TV plus TW for all VW in V. And second thing is T of alpha V is alpha times TV for all V in V. So this is called as linear transformation. And other thing is what you define using the Nevian transformation. So TV is 0. So null space of T is defined as V such that TV is 0. V in V such that TV is 0. Okay. So the vectors V which are mapped to 0 are called 0 vector in W because W is vector space. So those vectors are called the elements of null space and is called, this set is called the null space of T. Okay. Is it clear? Then what is the null space of a matrix? So there is a way. So if V is, you write as, if your V is say Fn and W is Fm, where so Fn is like F direct product, F product with F. It's like a tuple, and this is n times, and F is a field. Okay, and Fm is like this, same, m times, and again F is a field. Then if you have T from V to W, sorry, because V is now Fm to Fn, Fm to Fm, then T can be written as T with respect to some basis beta, sorry, beta gamma can be written as a matrix A. So you know how to write how to write a linear transformation with respect to the basis? Anyone? Beta is a basis of Fn and gamma is basis of Everyone knows this or not? Suppose, for example, t is from R2 to R2 and txy is same as xy. Suppose this is like an identity map. Then what is the basis of R2? You calculate at the basis. Calculate at basis elements. There is someone here. Wait, what is? Yes. Yes, calculate at the basis element. So what is the basis of R2? What is the basis of R2? So I just rub this. Yes, tell me. Try it just like everyone doesn't come on time. Wait a second. I have to automatically admit everyone. So right. So what is the basis of R2? Say beta, which is 1 0 and 0 1. This is your basis. So t1 to you calculate the value of t at the basis. So which is t10 is 1 0 and t01 is 0 1. Okay. So then you have, so you can write it as 1 times 1 0 plus 0 times 0 1, and similarly this has 0 times 1 0 and 1 times 0 1, and you just pick these up and you write as this with respect to beta, because beta is same as beta beta, or you say t beta, then it is right 1 0. You just pick these into the columns and other into the other also columns. So this is a, so you get a. All right, let me see who is there. uh, in the lobby again. Okay, we have to admit everyone later on. Yes. So is it clear, everyone? What? How do you get A from linear transformation T? So this is very clear. Next is, so null space of T means if it is a finite dimensional vector space. So V and W are finite dimensional. They are finite dimensional. If they are not finite dimensional, then you can't associate like this. Okay, so try to calculate the null space of the following question. I write a question and you have to do it. So if you have, okay, so I just, wait. Let's write a question. Suppose I'm giving you a matrix question. Calculate the null space of A, which is equal to 520, 5210. Yes, calculate that. You have 5 minutes and tell me. Yes, how do you do that? How do you find the null space of this matrix? So to find the null space, you have, so I told, I forgot to tell you one thing, that is, so if you are having this type of A belongs to a matrix 2 by 2 over R, right? So what is the linear transformation associated to A? R2 to R2, and Tx is Ax, where x is in R2. So you have to calculate Ax is x such that Ax is equal to 0 to find the null space of A, right? So what is that x? So 5, 2, 1, 0, x1, x2 should be 0, 0, and x1, x2 is in R. So what is that x1, x2? So you have 5x1 plus 2x2 is 0, and x1 plus x0, x2 is 0. It implies x1 is 0 and x2 is 0. So null space of A has only 0, 0 vector. So null space of A is also the subspace of R2. In fact, null space is always a subspace of a vector space. And other thing is to say is, what about the dimension? Anyone? What's the dimension of null space of A? What is, how do you calculate the dimension? Number of elements in the basis. So what is the basis of null space? In this case, any linearly independent vector that spans. So there is no element in the basis because 0, 0 is only vector. So dimension of NA is 0 as basis is empty. Okay. Is it clear to everyone? I just write remaining some questions based on that. You try them. So you are given the, consider the vector find null space of A and dimension. Second thing is um, for this matrix. And third thing is for linear transformation from R2 to R, Txy is x plus y. Okay, just try that. Just try to do that. Take your time. Anyone is there that? Yes. Try these questions. Um, Wait a second. Why it's always. Yes, tell me, have you tried that? Just a second. Yes, what are the answers? Anyone? So for the first one, you have 1, 2, 3. Have 1, 2, 3. Wait a second. For 1, 2, 3 and 0, 0, 2 and 0, 0 minus 1. So you have to solve again Ex equals 0 where x is in R3. So x1 plus 2x2 plus 3x3 is 0, 2x3 is 0, minus x3 is 0. So it implies that x3 is 0 and x1 plus 2x2 is 0. It implies that x1 is minus 2x2. So what are the values in null space of A now? X1 minus, so these values are basically minus 2x2, x2 and 0. So it will be minus 2, 1, 0 times x2. So these vectors lie in null space. So it's kind of, so what is the dimension of null space? Because there is only one non-zero vector, so dimension will be 1. Is it clear? Similarly, you can do the second question. What about the third one? That is txy is x plus y. So to find null space, again you do txy is 0. It implies x plus y is 0. It implies x is minus y. So you get the vector as x comma minus x such that x is in R. So you get the dimension of NT to be 1 because there is only one vector. So these are the tricks. All right. Yes. So these are all basic things to calculate the null space. So I want to discuss another question with you. So there is a theorem which says that rank nullity theorem. Okay, what is rank? So if your T is from B to W, then whatever x Tx such that x is in V, then you make a set which is called range of T. Then it is called the range space. And if you calculate the base dimension of this range space, so rank is dimension of range space of T. So rank is dimension of range space of T. That's easy to see. Then there is a rank nullity theorem. So rank nullity theorem says that range, so if you have T from B to W, a finite a linear transformation, Then rank T plus nullity T is dimension of V. That is your rank nullity theorem. So it works only for finite dimensional vector spaces. Then we have a question which says that can you use the rank, sorry, use the rank nullity theorem to answer this. A is a matrix such that all rows of A are linearly independent. Then dimension of null space of A is what? Rank of A transpose is what? And yes, you have to calculate this using the rank nullity theorem. So you have some time for that. Just try using that. That's an application. Okay. Just try that. Yes, have you tried that? Mm, I can't see the participants in meeting. Okay. Yes. So how do you use the rank nullity theorem in that case? Anyone? Any one of you wants to answer? What's the dimension of null space of A?
0.
Why? All rows of A are linearly independent, right? So what does it mean? So what's the dimension of V? What's the dimension of V first? For the rank nullity theorem, you should know the dimension of V, right? What is the dimension of V? Anyone? M or N?
N.
Yes, because A is from, so A is M by N matrix, right? So the linear transformation is from Fn to, wait, Fn to Fm. Yes. So that's why the dimension is N. Dimension of V, since V is Fn, so dimension is N. Next thing is, what is the dimension of null space of A? As you said, the dimension of null space of A is 0. Let's check why is that. So AX is 0. X such that AX is 0. So since A has all linearly independent rows, right? All rows they are linearly independent. So if all rows of A are linearly independent, then rank of A is N. That you can check. The rank of A will be your N. Yes. And the null space of A is, okay, wait. All rows of A are linearly independent. What does it mean? So there are m rows and n columns. So it means that the rank is, because there are, why is that? If we are considering, so A is m by n matrix or n by n, if I'm considering in this case. Wait, A is m by n. Yeah. Yes. Yes. So rank of A is n, and no, because all rows are linearly independent, it means that rank of A is m, not n. Is it clear? Because rows are linearly independent, columns are not linearly independent. I'm saying about the rows, and there are m rows. So nullity of A using, so what happened is that by rank nullity theorem, nullity of A means dimension of null space of A is n minus m. Okay, since rows are linearly independent. Is it clear? If columns are linearly independent, then it should be 0. Clear? Okay. If it is clear, then what is the another question that I can have is, I will discuss about the Wronskian, but first let me see about the diagonally dominant. So there is a thing like strictly diagonal dominant matrix, coefficient matrix. So I discussed that, but before that, I want to discuss something. Yes, for before that you just have one more question for null space. You try calculating that. So what is the basis of null space of A, null space of A where A is 200 100 982. So try to calculate the basis of null space, and yes, just do that. Who else is waiting in the lobby? No one. Okay, just try that. Yes. So, so anyone, what is the basis for null space of A in this case? Yes, 2x1 is 0. So I just start again. So for the null space, you do have ax is 0, x is x1, x2, x3, then ax is 0. It implies 2x1 is 0, x1 is 0, and 9x1 x2 plus 2x3 is 0. So it implies x2 plus x3 is 0 and x1 is 0. So you do get in null space of A, you do get this type of thing 0 minus so x3 and minus 4. Wait, so this implies x3 is minus 4x2. So you have x2 and minus 4x2, right? So you do get this type of thing 0, 1, minus 4x2. So it means that there is only one vector. So you just say that dimension of n is null space of A is 1 in this case, and it is the span of 0, 1, minus 4. Is it clear? Okay. The next thing I want to discuss is about the Wronskian. So if you are having two functions, say ft and g of t, then Wronskian of f and g is determinant of f, g, f prime, g prime. So it is basically f g prime minus f prime g. So if Wronskian is non-zero, then for all t in R, then f and t linearly independent. Okay. If Wronskian is non-zero, then f and t are linearly independent. So now is your task is if ft is 1 minus t and gt is t cube, then ft and gt are li or not. Just check this. So it's your task. Just check in 5 to 10 minutes. Yes. Have you tried that? There are very less people in the meeting now. Okay, so what about the Wronskian? So I just write W of f and g is determinant of 1 minus t cube, and you have to calculate the derivative of ft, which is minus 1, and this is 3t square. So you end up with 3t square, 1 minus t, and plus t cube. So the Wronskian is always non-zero or not? That's the question. Yes. Anyone? So it is basically 3t square minus 3t cube plus t cube, which is same as 3t square minus 2t cube. Same as 3 3 minus 2t.
వద్దులేదు తీసేస్తే మరి బోర్డ్ అయిపోతుంది.
Yes. So the Wronskian can be 0 when t is equal to 3 by 2. When t is 3 by 2, then WFG is 0. So f and g are linearly dependent. Is it clear, everyone? Who is speaking? Yes, Palla is. I have to mute you. Okay, how do Palla is, can you mute your mic? Okay. So yes. Next thing is about the. So these are two things that I want to share. Another thing is diagonally dominant, strictly diagonally dominant matrices. So if A is something like A1, A2, A3, A4, A5, A6, A7, A8, A9, then does it mean to be strictly diagonally or dominant? Means that modulus f value of A1 is greater than sum of A2 plus A3 diagonally elements, so it is greater than A4 plus A6. A9 is greater than A7 plus A8. So that is for strictly dominant. And for the diagonally dominant, you have this one equal to sign. All right. So these are two things that I want to share. So yes. So that's all from my side. If you have any questions, just let me know. Just look at these definitions. Yes, I'm done with the class. If you have any questions, you can ask. Pause for 2 minutes. I'm stopping now. Thank you.
Thank you, sir.